Hello again. In our last video, we learned how to find the distance and midpoint between 2 points on the coordinate plane. Now we're moving to a new idea. That idea is, how does an equation create a graph? How does an equation create a graph? Okay. So again, this is graphs of equations, intercepts, and symmetry. And this is part one, from equations to points. From equations to points. But the new idea is, how does an equation create a graph? So before we discuss intercepts or symmetry, we first need to understand the basic relationship between an equation and the points that appear on its graph. So let's begin with a simple equation. So the equation I want to begin with is y equals 2x plus 1. Now, this equation tells us that the value of y depends on the value of x. The value of y depends on the value of x. So for every value that we choose for x, the equation produces a corresponding value for y. So let's create a simple table. All right. One side I'm going to label x. The other side I'm going to label as our equation, 2x plus 1. Now, suppose I use these values, -1, 0, 1, and 2. So the question is, what would be the outcome of those values? So let's begin with, first of all, with the -1. We begin by substituting. So substitute -1 into this equation where we see the x value. So again, that would look like this. Y equals 2, parentheses, -1, plus 1. In doing this, 2 times -1 is going to give me -2. -2 plus 1 is going to give me -1. So our first point is, if I were to just create a table here, and I'm going to give us the x value and the y value panel column, which would be -1, -1. Okay. So again, y is dependent upon x. When x changes, so does y. Doing the same thing, we substitute y 2 parentheses 0 plus 1. 2 times 0 is 0, plus 1 is just going to give us a positive 1. So this tells us that that point is located at 0, 1. So our next position is 0, 1. Now let's do the same thing for the next two values. So y equals 2 parentheses 1 plus 1, which is going to be 3. 2 times 2, or 2 times 1 is 2, plus 1 is 3. This gives us a value of 1, 3. The next is y equals 2 parentheses 2 plus 1. 2 times 2 is 4. 4 plus 1 is 5. So we have 2, 5. Okay, so that completes the table. Now, each row of this table gives us the ordered pair. -1, 1, 0, 1, 1, 3, 2, 5. Each of these points satisfies the equation. Each of these points satisfies the equation y equals 2x plus 1. So that means that each point belongs on the graph of the equation. If we were to graph this, each one of these points would be on the graph of the equation. So I'm going to show you something. If I were to graph these, going back to what we looked at the very beginning of this course, which is a Cartesian plane, I'm going to do 5 values in each direction. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 in the negative direction. And then 1, 2, 3, 4, 5 in the positive direction. And 1, 2, 3, 4, 5 in the negative direction. Okay, and again, this is the y-axis, and then this is the x-axis. Okay, so I'm going to plot these points. We have -1, -1. So again, starting at the origin, we go -1 units, and then we go down 1 unit. So that is where the first point is located. Again, -1, -1. So that's to the left 1, down 1. The next point is 0, 1. So we're starting at the origin, we stay there, and we go 1 unit up. Okay, that puts the second unit on the Cartesian plane. The next thing we're going to do is go 1 unit horizontally, 3 units up. 1 unit horizontally, 3 units up. 1, 2, 3. That'll put us here. Finally, we have 2 units horizontally in the positive direction, 5 units vertically in the positive direction. So 2 units, 1, 2, up 5 units, 1, 2, 3, 4, 5. So that puts us here. Notice what it creates. This creates a line. So that is the main idea. When we plot these points, we begin to see a pattern. In this case, the points lie on a straight line. Okay? The points lie on a straight line. The graph of an equation is simply the collection of all ordered pairs that make the equation true. And that's the main idea that I want you to understand. So a point belongs to a graph if its coordinate plane, or excuse me, coordinates makes the equation true. And that is the big idea. So in the next video, we will take this idea one step further and test whether specific points belong to the graph of an equation without creating an entire table. Hope to see you in the next one, and thanks for watching.